Mercedes, BMW, Toyota, Volkswagen, almost every major car manufacturer has now tried to build a solid-state battery. They promise ranges of over 1,000 kilometers, very short charging times, and greater safety than conventional lithium-ion batteries. So can car manufacturers finally deliver on the promises they've made in recent years? Watch this video to find out whether we will be able to buy cars with solid-state batteries as early as next year, or whether the whole thing will be delayed for another few years. And with that, welcome to the German Science Guy. I'm Dr. Jakob Beautemps, and in Germany we say Los geht's. Solid-state batteries have been considered the next big thing in the battery sector for years. And that's no surprise. The advantages seem to solve all the problems that still exist with conventional lithium-ion batteries. And yet, there's still no electric car with a solid-state battery. Every now and then we read that the breakthrough has been made, and then the market launch date is pushed back again and again. To find out whether something is actually happening, we spoke to experts in the field of solid-state batteries, Professor Jürgen Janek and Dr. Joachim Sann from the Institute of Physical Chemistry at the University of Giessen here in Germany. We'll come back to that in a moment, but first I want to briefly recap how solid-state batteries work. Solid-state batteries and lithium-ion batteries work on the same principle. They have a positively charged cathode and a negatively charged anode, as well as an electrolyte, so to speak, an ion conductor that transports ions back and forth between the electrodes. And here's the difference. Lithium-ion batteries usually have a liquid electrolyte. Solid-state batteries, as the name suggests, have a solid electrolyte. They're particularly thin and can therefore be stacked individually. The US company QuantumScape has already tried this and developed a battery with 24 layers. Two groups of materials are suitable for solid electrolytes: polymer electrolytes and ceramic electrolytes. The problem here is, however, that polymer electrolytes have fairly low conductivity and therefore a relatively high operating temperature. This means that the batteries have to be preheated. Of course, this is not suitable for everyday use. That is why ceramic electrolytes such as oxides or sulfides are more commonly used. They have higher performance and energy densities, but their development is quite complex, and both oxide and sulfide electrolytes have their own challenges. The design and materials offer precisely the advantages I mentioned at the beginning. So solid electrolytes are safer because they are non-flammable, they have a higher energy density and can therefore be built more compactly or have a longer range, and they have a potentially longer service life. So that was just a very brief overview of the topic. And just to say, solid-state batteries are most interestingly, of course, for e-mobility, so cars, buses and trucks. Actually, polymer electrolytes are already in use today, for example, in buses. And there are currently lots of exciting reports about solid-state batteries from various car manufacturers. But we have to take a closer look at these and then assess whether there's any truth to the reports, or as we say in German, es ist alles nur heiße Luft. It is important to note, as Dr. Sann, who I spoke to, has pointed out, that car manufacturers often specify ranges as a parameter for their models. However, range depends on many factors. Is it winter or summer? Was the car driven on the highway or in city traffic? And so on. I will give you the ranges specified by the manufacturers, but such figures should definitely be treated with caution. Let's take a quick breath. Have you guys heard of video hyping? It's a totally free way to support the channel. By hyping a video, you're basically giving it a boost so YouTube shows it to a much wider audience. All you have to do is open the YouTube app on your phone, swipe left on the comment preview and tap hype twice. It takes maybe 5 seconds and honestly makes a huge difference for me. Quick note, you are only able to hype videos that have been released within the last 7 days, but if you would do so, you would help me to reach more people, and yeah, that would really help my channel, would help me to make better videos. I just wanted to mention it because somebody mentioned it in the comments that I should do this, and I think it's a really good idea. So thank you very much for the idea in the comments, and let's go on with the video. But let's start at the beginning. This year has seen some pretty successful test runs. The first production facility for solid-state batteries has been built and the figures are becoming increasingly impressive. If you take a closer look, quite often these are not actually solid-state batteries, but semi or quasi-solid-state batteries. In other words, solid-state batteries that still contain a small amount of liquid electrolyte. Research into these batteries, which are also known as gel polymer batteries, is being conducted primarily in Asia. Their aim is to develop these batteries step by step until they become a fully solid-state battery. And therefore, the liquid electrolyte is gradually being reduced. This may not be a major revolution, but it does represent continuous progress. And these quasi-solid-state or semi-solid-state batteries also have the advantage of being able to withstand extreme cold weather than normal lithium batteries. And actually, this is a critical issue for solid-state batteries, especially in Asian countries where temperatures can sometimes reach minus 30 degrees Celsius. Semi-solid state batteries are currently making up a large part of the news, so let's take a closer look at two examples. First, the MG4 from Chinese manufacturer SAIC Motors is currently said to be the first car with a semi-solid state battery to go into mass production. In the case of the MG4, this means that the battery still contains 5% liquid electrolyte. According to the manufacturer, the manganese-based battery has a range of just under 530 kilometers, not much more than electric cars that are already on the market. So the battery is not necessarily better than current batteries, it is even heavier and has a poorer energy density. But the motivation for this model is not necessarily to achieve a dramatic increase in range. Dr. Sann believes that the aim here is to develop a car that can operate in more extreme climates of up to minus 30 degrees Celsius, which is why the semi-solid state battery is being used. The MG4 is also a good example of the approach taken by Chinese car manufacturers. According to Dr. Sann, it is not necessarily about bringing a technology to market that is significantly better than what already exists. So the market is used more as a testing ground to improve the product, unlike in other countries. For example, in Germany, this experience tends to be gathered behind closed doors. They don't share it a lot. But semi-solid state batteries are not only a thing on the Asian market. Mercedes is also making moves in this area. They have now equipped their EQS with such a battery. In September, the first test drive under real-world conditions was conducted with it, and the results were impressive. The EQS made it from Stuttgart in Germany to Malmö in Sweden, a distance of almost 1,200 kilometers, without a single charging stop. According to Mercedes, the battery is the same size and weight as the lithium-ion battery normally installed in the EQS. But, and this is a key advantage, it has 25% more energy content. Mercedes is relying on FEST technology. This stands for Factorial Electrolyte System Technology, and it comes from the US company Factorial Energy. And a small fun fact, FEST in Germany also means solid. Mercedes says that the EQS with a solid-state battery should be available sometime before 2030. However, our expert, Dr. Sann, emphasizes very clearly that this model will definitely not be cheap and will remain a premium model. So the quasi-solid-state battery is the first generation of solid-state batteries from Mercedes and Factorial Energy. But the companies are already developing the second generation, a sulfide-based all-solid-state battery. This is expected to be even more powerful than the first generation and has an expected energy density of 450 watt-hours per kilogram. For comparison, currently we have an energy density of up to 330 watt-hours per kilogram. The battery is definitely also planned for use in electric cars, however, there are no further details available yet. And that's actually the perfect transition to the next news that really concerns all solid-state batteries. Volkswagen, for example. They haven't unveiled a car with a solid-state battery this year, but they have unveiled a motorcycle. It was produced in cooperation with the US battery company QuantumScape. The battery has a ceramic solid electrolyte, which is said to be particularly temperature stable and safe. And according to Volkswagen and QuantumScape, the battery also delivers on all the other promises of solid-state batteries. It can charge from 10% to 80% in 12 minutes. It has an energy density of 301 watt-hours per kilogram and can be recharged up to 1,000 times without significant loss of capacity. And the battery has another special feature. According to QuantumScape, the Ducati motorcycle is the first vehicle with a solid-state battery without an anode. This saves space and weight, which ultimately allows for higher energy density. Almost all battery manufacturers are researching such anode-free batteries. QuantumScape now seems to have succeeded. Dr. Sann also finds this technology exciting, but sees one major problem, and it is affordability. Manufacturing anode-free batteries requires completely new production facilities. This is, of course, very costly and also slows down the process considerably. But that's a whole other topic, and if you're interested in how exactly anode-free batteries work, feel free to write it in the comments, and if there is enough interest in it, I will make a separate video about it. Okay, but back to Volkswagen and QuantumScape. As I mentioned, the battery was initially only installed in a motorcycle. This serves as a mobile laboratory to prepare for the next step, scaling up from a motorcycle to cars. One goal is also to bring cars with solid-state batteries to market before 2030. But these are not all news. In addition to Volkswagen, BMW is also working on an all-solid-state battery. They are currently testing a solid-state battery with sulfide-based electrolyte in its i7, in collaboration with battery company Solid Power and Samsung SDI. According to the manufacturer, the model is expected to deliver 440 watt-hours per kilogram and over 1,000 life cycles. So it's also pretty powerful. However, these are only solid power targets for now. How much the i7 can actually achieve is currently being tested with a prototype, so there are no concrete figures available yet. Nevertheless, BMW wants to start production in 2028. And then of course there's Toyota. I already researched about their breakthroughs in solid-state batteries years ago, and many people I spoke to were quite skeptical. Toyota has been promising a major revolution in solid-state batteries for years, and then they keep postponing the market launch. The solid-state battery was supposed to be launched in 2020, then it was 2023, then 2026, and now we've already reached 2028. So it's no wonder people are skeptical. And indeed, there's just been more bad news. Toyota wanted to build a factory for solid-state batteries in Japan this year. However, the start of construction has now been postponed for the second time. According to Toyota, this is because demand for electric cars is lower than the company had expected. The plans have not been completely scrapped yet, but Toyota is not saying anything about exactly how things will proceed from here. But still, instead of the new factory, Toyota has announced something else. The president of Toyota's development center has announced a solid-state battery that lasts 40 years and retains 90% of its initial capacity. If the battery really does last that long, it would probably exceed the lifespan of the entire car. And this means it could simply be reused in the next model. But such a battery would of course probably cost much more than a battery that only lasts 10 years. Our expert Dr. Sann has not lost faith in Toyota, however, simply because Toyota has been investing a lot of manpower in solid-state battery research for almost 15 years now. Okay, but what does all of this mean? Whether solid-state batteries will actually be available in the next few years or whether there are too many hurdles to overcome is something we will now clarify in the big hurdle of this video. It is this part of the video where we look at the hurdles and limitations of an innovation. It's something I do in every video, and if you like it, please feel free to subscribe. I really hope to reach 100,000 subscribers this year, so this is a major goal for me and you would really help me if you do so. Okay, let's jump into the big hurdle. So despite all the hype, there are of course a few points that can be criticized about solid-state batteries. I've already talked about a few technical disadvantages such as dendrite formation and service life in other videos on this channel. That's why the big hurdle today mainly focuses on what needs to happen for cars with solid-state batteries to actually become reality. According to Dr. Sann, the biggest technical problem right now is a combination of advantages. It is currently possible to build a solid-state battery with an extremely long service life, or with a top charging rate, or one that works at low temperatures. But incorporating all of these features at the same time is currently very difficult. And in the end, it always comes down to a question of costs. The economic aspect is probably one of the biggest obstacles to market launch. For solid-state batteries to really catch on, they can't be more expensive than current models. The biggest cost factor is of course the lack of infrastructure. Our experts told me that semi-solid-state batteries can be manufactured in part on existing production lines and could therefore be available faster and cheaper. But real solid-state batteries cannot be manufactured in the factories that currently exist. That's why new production facilities have to be built first. This is already happening, but it is of course very expensive and above all a long process. But as Professor Janek told me, gigafabs also means giga-invest. According to him, in the long term, car manufacturers will have no choice but to make such investments if they want to bring solid-state batteries to market. So what does this mean? When will solid-state batteries hit the mass market? I remember saying in a video, I think 5 years ago, that 2025 would be a magical year for solid-state batteries.
Das Jahr 2025, das scheint irgendwie so ein magisches Jahr zu sein, wenn es zum Beispiel halt um die Marktreife von Feststoffbatterien in Elektro- und Hybridfahrzeugen geht.
Obviously, that didn't quite work out as expected, although, as I said, there have been some minor successes this year. But even if there are still a few technical and economic issues that need to be ironed out, Professor Janek and Dr. Sann and myself, we all believe that solid-state batteries are coming. I doubt that Toyota and co will really make it to the mass market within this decade, but the hype is definitely not dying down, and now every car manufacturer wants to be part of it. So maybe we will actually see the first premium models with solid-state batteries on the market in 2030, and on the long run we will drive them ourselves as a regular market. But I will be honest with you, I don't know if such models will even be relevant for the average driver in the coming decade. I also talked to Dr. Sann about this. Lithium iron phosphate has become a relatively cheap technology. The cars have a range of around 500 kilometers and can be charged in 10 minutes. That's actually enough for most drivers. Cars with solid-state batteries will probably be able to drive longer distances and charge faster, but they will also cost significantly more at first. However, once premium models with solid-state batteries become established, the tide may turn again. But that will definitely take at least another 10 to 15 years. That's why I believe that we are more likely to see cars with semi-solid-state batteries for the mass market. And to be honest, as long as they work and perhaps even have a longer range, I'm very happy with this type of battery. But what do you think of the latest developments in solid-state batteries? Let me know in the comments, and here's a video I really recommend it to you. I was at a facility that should recycle atomic or radioactive waste. And I actually been on site, talked to the startup, and I think it's a really cool video, but not so many people have watched it. So do me a favor, watch it and tell me in the comments if you like it. And I say auf Wiedersehen, which means goodbye in German. Thank you for watching, your Jacob.